In this kinematics problem, we're given an acceleration time graph for a cart that we're told starts from rest at the origin, meaning the initial speed is 0 and it starts at an x-coordinate of 0. Now the car moves in a straight line according to this acceleration time plot, where we can see for the first 5 seconds, the acceleration is 5 meters per second squared, and then it suddenly switches to decelerating. It has an acceleration of -3 meters per second squared for the following 4 seconds, and then the process ends at t = 9 seconds. In part A, we're trying to find the speed of the cart at the end of the process, and probably the quickest way to do this is to just look at it in terms of geometry. So remember, the area bounded by an acceleration time graph gives you the change in the velocity, and the initial velocity was just 0. So all we have to do here is find the signed area bounded by the graph, and that'll give us our final velocity. So this first rectangle, actually it's a square, that counts as positive area because the acceleration is positive, and my height there is 5 meters per second squared. It's instructive to keep the units on this. So my height is 5 meters per second squared because those are the vertical units, and the width of that guy is 5 seconds. Then the area down here, when the acceleration becomes negative, this is signed area again, so that's going to count as negative. I mean, basically what we're doing here is finding the integral of this graph, but we can just talk about it as area. So that height counts as negative. I have a -3 meters per second squared, and then the width of that is 4 seconds. And I just wanted to point out that the units do work out here. I can cancel 1 factor of seconds out of each of these terms, and I end up with meters per second, so our final units are making sense. That first term gives us 25 meters per second, and then we have -12 meters per second, giving us a final velocity of positive 13 meters per second. Now I did ask for the speed and not the velocity, but because this is already a positive number, like the speed is going to be 13 meters per second as well. So that's our final answer. Now in part B, things get a little more complicated because I'm asking for the total displacement of the cart during this process, but we have 2 different accelerations occurring. Now our equations for kinematics, they only apply to a constant acceleration process, and that means we need to break this into 2 pieces. So I have to break it into the first 5 seconds, do the analysis there, and then tack on the additional displacement that happens during the following 4 seconds. So we'll just do a quick analysis of the first part. Again, my cart starts from rest at the origin, so that means initial position and velocity are 0, and it accelerates at 5 meters per second squared for 5 seconds. So we're using our first kinematics equation here, x = x naught plus v naught t plus 1/2 at squared, but our initial x value is 0, and our initial velocity is 0. So this gives us just 1/2 at squared. Our acceleration is 5 meters per second squared, and the amount of time this happens for is 5 seconds. I'm going to go ahead and be lazy and not write the units in there, but if you find them helpful, there's certainly no problem with it. And I end up with a 5 times 25, which is 125 divided by 2, giving me 62.5 meters for the displacement in that first leg of the process. Now in the second leg of the process, we're going to do a similar thing, and we're going to use the same equation, but we need to figure out what the velocity is at the beginning of the second part of the process. So I mean at t = 5 seconds. So we could just go back to our original area calculation if you want to do it that way and just say, oh, the velocity after the first 5 seconds, that was 25 meters per second, right? It's the bounded area under the acceleration graph for the first 5 seconds. That's 25 meters per second. So we'll just make a note of that. So just making a note here, v naught is going to be 25 meters per second when we start the second leg of this process. And then I just go back to my same kinematics equation. All right, but this time we have a non-trivial starting point, that's 62.5 meters. We have a non-trivial initial velocity, that's 25 meters per second. And this process occurs for an additional 4 seconds, so we'll go ahead and plug t in right now. And then our acceleration is -3 meters per second squared, so I'm going to move the minus sign out in front here. And just call this -1/2 times 3 times t squared. Again, t is 4 seconds for the second leg of the journey. And when I run the numbers on this, I get 138.5 meters. That's a fine way to leave the answer. In my classes, we traditionally round everything to 3 significant digits, so I might say 139 meters. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.